Hello, my name is Mark Setter, and I'm here today to talk to you about some contemporary instrumentation relative to dental extractions. I've been a practicing periodontist for over 30 years, and as we all know, dental extractions can be some of the most frustrating things that enter your day. The instrumentation that I'm going to share with you today had its origins back with Pierre Fauchard over 100 years ago. What you're about to see has design features that make it the next generation, really, of this type of extraction technology. I'm excited to share with you the instrumentation that you're about to see.
The pliers, which acts like a traditional dental forceps. Trying to take a cap off a bottle, you'd position it, you'd have trouble getting it on place, you'd damage the cap while you try to hold it, and all the force is there to hold the cap, and then you have to hold the bottle down, and you have to try to pull this cap off. And all you end up doing is damaging and breaking the bottle because all the force is made to hold the cap when you use a plier. Somebody that understands biomechanics would use a lever. And you have a fulcrum and two lever arms. And the fulcrum's applied and the cap is removed. Instead of using a traditional dental forceps, which holds the tooth and we have to hold the head steady and we have to physically remove the tooth, and if the tooth has endodontics, we crush the tooth and it fractures, and we never know how long the procedure is going to take. We can take an instrument that is a lever, and it has a fulcrum, and you can position it, and you can position it and remove the cap.
If your office is anything like mine, you have a drawer full of instruments used to take teeth out. When I ask my assistant for the instruments to remove an upper right posterior tooth, it's not unusual for her to bring 2 or 3 bags of instruments. With these universal instruments, 2 is generally what it takes to get a tooth out of the socket. The beak is the portion of the instrument that engages the tooth at the cervical. You'll notice the beak is very sharp and will engage a tooth if it has at least a millimeter or so of tooth structure. You also have the fulcrum pad, which you notice is articulating and has one side longer than another, so it can be best suited for the anatomy of the tooth in the area. To use this instrument, you place the beak at the cervical of the tooth first, and then position the fulcrum pad where it is best suited to elevate the tooth. Now, in these instruments, it's really different than a conventional forceps. You're not really pulling the tooth. You're not luxating the tooth, you're elevating the tooth. And to elevate it, it takes constant pressure over a few minutes, actually, to slowly break the periodontal fibers until the tooth will pop.
And you rotate it for a few degrees with about as much pressure as picking up a glass of water. And you hold it there for a period of 10 seconds. That 10-second pressure creates creep in the periodontal ligament. You know that creep is a constant load, which over time causes the material to change shape, deformation, and then fracture. Well, the creep then starts on the periodontal ligament, and that starts what we now know an enzymatic reaction that literally start breaking down the periodontal ligament first through creep, and then the addition of this enzymatic release from that pressure.
Now, unique to this instrument is the fact that you can position the beak on the lingual, fulcrum pad buccal, but you can also change the instrumentation to have the second instrument engage the tooth on the facial with the fulcrum pad on the lingual. And many times that's what you find on upper teeth that have fractured cusps. Now, this palatal positioning of the fulcrum pad is unique to this instrument, and that's where the articulating head and the longer beak on one side as opposed to another will allow you to engage for any tooth in the palatal arch. The pressure you apply is constant over a few minutes, much like, I look at it like Velcro releasing, that you apply pressure to the tooth and 1 fiber, 2 fibers, 10 fibers, 50 fibers give way until finally the tooth gives way a millimeter or so. When that occurs, you stop using this instrument and deliver the tooth with basically any instrument that can grab the tooth. You utilize this instrument by adjusting the distance between the fulcrum pad and the beak with your hand, and then maintain that position utilizing a rotational wrist-only motion to elevate the tooth. And so forget the idea of squeezing. This is not a forceps. This is an elevator. And to use the elevator, you have to position the beak and the fulcrum pad correctly. And that involves a hand position with fingers on the outside, fingers on the inside, and adjusting the distance between the beak and the fulcrum pad. So let's go through the procedure of removing a tooth. As you well know, the initial procedure in taking a tooth out is relieving the epithelial collar. At first, the extraction sequence involves relieving the gingival collar with a narrow-bladed instrument. Complete epithelial collar relief releases the periodontal ligament fibers that are supracrestal. The next step in the extraction sequence is to decide which side of the tooth is best suited to have the beak attachment occur. It's critical to place the beak at the cervical area of the tooth as close to the bone as possible. The fulcrum pad then goes in the vestibule. Now, it's not unusual to need a gauze pad in this area so that the fulcrum position is placed a little more labial as that tooth is elevated. I can position that fulcrum pad anywhere in the buccal based on the thickness of the gauze pad to get more coronal movement than buccal movement. If there's an undercut in the vestibule and you position the fulcrum pad in that undercut, you get quite a bit of buccal movement of the tooth, and there is a risk of fracturing the buccal plate. And so by putting a gauze pad in there, and it's not unusual for me to use 3 or 4 gauzes in that, position a wad of gauze in the vestibule, you engage the lingual on the gauze pad, put the fulcrum, and at that point now you can adjust where that fulcrum point is. And at that point delivering a rotational force, but it's a constant pressure. It's not a luxation. So it's a rotational force, constant pressure, increasing pressure until the tooth pops. Which instrument to use depends on how much tooth structure you have on the facial, how much tooth structure you have on the lingual, and where the best fulcrum pad positioning occurs. Many times in the maxillary anterior, the undercut is so severe that this fulcrum pad gets underneath the tooth. So attempting to elevate the tooth with that delivers way too much buccal force, compromising the facial plate. So you have 2 choices. You can either build the gauze out or switch instruments to using the fulcrum pad on the lingual. And so realizing that there's a long side and a short side, you may need to rotate that fulcrum pad in order to get it positioned in the palatal area. And at that point, you can use this to deliver a maxillary anterior tooth, not delivering it to the facial, but rather using the fulcrum pad on the lingual. So once the tooth pops, once you get the tooth to elevate a millimeter or so, this instrument's done its job. The tooth is basically mobile at that point. Then you can use any instrument, a hemostat, a rongeur, to take the tooth to final delivery. So to repeat, you relieve the epithelial collar, you determine which area of the tooth is most suitable for beak engagement, and which area of the arch is most suitable for fulcrum positioning. It's not unusual to use both instruments on one tooth, attempting to get elevation, rotating to the facial. If you're not getting movement, switch instruments and go to the lingual. Now we need to talk about multi-rooted teeth. In the lower arch, multi-rooted teeth, lower first molar primarily, it's common to section that tooth because attempting to deliver that tooth intact can lead to root fracture more commonly, and it takes way higher delivery forces to get that tooth to release. So sectioning through the furcation and basically treat that tooth like 2 lower premolars would allow that tooth to be delivered much like any other lower arch tooth. On the upper arch, multi-rooted teeth can be sectioned if the roots are highly divergent. But if the roots are are common in divergency, it's not unusual to be able to deliver an upper molar without sectioning and without root fracture.
This instrument has been so efficient for me that I'll first spend 10 seconds to the buccal, 10 seconds to the lingual, repeat that to the buccal and lingual. Most often the tooth has been extracted by then. If not, then I'll segment a molar and then take the roots out individually from each other.
With these two, you can deliver most teeth in a very predictable way and make dental extractions a routine part of your day.
It elevates the tooth from the socket like a bottle opener or a claw hammer for a nail. It's using physics to elevate the tooth from the socket.
This instrumentation makes extractions predictable, not time-consuming.
Visual feeling in my mouth. I don't.
Did you rough it?
It's numb.
Yeah, especially with the roof of the mouth being numb. You know. Interesting you didn't feel it that time. Let me try this one that you felt last time. Are you okay there? Okay. Into 15 seconds. One, 1,002, 1,003, 1,004, 1,007. Same thing to the other side. Do the same for him. A couple times. 7, 8, 9. You see the fractured piece is starting to get easy.
Oh.
Did you see that?
Yep. The mesial or distal portion?
The buckle just rotated it 2 millimeters to the buckle. See?
Yep. Saw that too.
You see it rotating out to the palate?
You might have a better angle as far as it in relation to the gum line, but
Let's see if it's ready to come now.
oh. There you go.
You okay, Paul?
Yeah, it's the first thing.
There's no water. There's nothing really in there.
Nothing you can hold up.
Okay. You're fine. Open.